A summary of what we have said in this lesson: when you want to find the equation of a normal, equation of a normal, the first thing is to get the gradient function. Depending with the equation that you are given, the gradient function. From the gradient function, you can now get the gradient at that point, the gradient at the point given, the gradient at the point. And this gradient at the point is the same as gradient of the tangent. But now we want to find the equation of the normal. So you move ahead and get the gradient of the normal at the point. The gradient of the normal at the point. Then after getting the gradient, now you can use the gradient. Then you have the point plus the imaginary point, and then calculate the equation. Because when you have the gradient, you have a point, maybe you have a point, an imaginary point xy, and you have a point, let's say 1, 2, you can use this now to get the equation of a normal. So ensure when you are calculating the equation of a normal, ensure that you have the gradient of the normal. You also have a point and an imaginary point. So depending with the equation, you just ensure that you have this, and then you'll be able to calculate the equation of the normal. I would like you to do the following questions. Question number 1. Given the curve y is equal to x cubed minus 3x minus 1, find the equation of the A, the tangent, B, normal at the point 1, negative 3. Question number 2. Find the equation of the tangent and the normal to the curve y is equal to x cubed minus 2x squared minus 1 when y is equal to negative 1. Finally, find the point on the curve y is equal to x squared minus 3x plus 7 at which the gradient is 5, and the equation of the tangent and the normal at this point. Ensure that you do those 3 questions so that during the next lesson we can look at what we refer to as the stationary points, that is in a curve, the stationary points. Thank you for being attentive. Let us meet next lesson.